This is a GCSE higher revision lesson on surds and indices. Okay, first of all, indices, index numbers, powers.
Hey Mark.
Hello Mr. Main. What does 2 to the power 3 mean?
Multiplied by 2, multiplied by 2.
Thank you very much Mr. Main. 2 times by 2 times by 2. I am recording
right,
this,
okay.
Mr. Main. This number here is called the base number, and this number here is called the index number, or sometimes called the power. The index number tells you how many times you multiply together the base number. 2 times 2 times 2, 2 cubed is 8. Okay. We can simplify calculations involving indices. In this first one here, 3 cubed means 3 times by 3 times by 3. So that is that part there. 3 squared means 3 times by 3. And when we multiply those two things together, you can see all together we're multiplying 1, 2, 3, 4, 5 threes together. So 3 cubed multiplied by 3 squared is the same as 3 to the power 5. Right, we can do something similar for division. 6 to the power 5 means 6 times 6 times 6 times 6 times 6. 6 squared means 6 times 6. This time we're dividing. I'm going to write it like this with a division line, and then every time we multiply by a 6 and then divide by a 6, they cancel one another out. So that one and that one cancel, and that one and that one cancel, leaving us with 3 6's. So 6 to the power 5 divided by 6 squared is 6 cubed. And then this bottom one, we've got 5 squared inside the brackets, which means 5 times 5, and we are cubing that, which means we are multiplying this by itself 3 times. So there's a second one, and there's a third one. If I put brackets around, should help you to see the 1, 2, 3. And obviously all together we're multiplying together 6 5s, so that's the same as 5 to the power 6. Now hopefully what you notice is that when you've multiplied, these index numbers have been added together. 3 plus 2 is 5. When you've divided, you can simplify by subtracting the index numbers. 5 take away 2 is 3. And then when you raise to 2 successive powers, 2 times by 3 is equal to 6. Okay. And that's what these rules up here say. Multiplying, you add the index numbers. When dividing, you subtract the index numbers, and when raising to 2 successive powers, you multiply the index numbers. You also need to know that anything raised to the power 1 is just that base number, and any number raised to the power 0 is equal to 1. There are 5 rules that you need to learn. Here's a couple more important ones. These are a little bit more complicated, so if I use some numbers to help explain them. Negative powers. 2 to the power minus 3 is the same as 1 over 2 cubed. The negative power is the same as 1 over the positive power. And for this one, this is fractions. 5 to the power 1/3 is the same as the cube root of 5. And 6 to the power 1/4 is the same as the 4th root of 6, and so on. A couple of other rules you need to be familiar with there. Okay, we can use those rules to simplify expressions involving indices. This is quite complicated and can be simplified a lot. First of all, the negative power. This is the same as 1 over the positive power, and this is the same as that. One divided by a half is the same as 2. Same kind of thing going on here. 1 over a fraction is the same as the denominator flipped round. Then this is the same as this. It's also the same as that. We can break that fraction up into 2 successive powers. and we do whichever one first, which is going to make the calculation easier to do. And in this case it's this one, because raising to the power third is the same as cube rooting, and both of these are cube numbers. So what do you times by itself 3 times to make 8? That's 2. And what do you times by itself 3 times to make 27? That's 3. But we've still got this squared here that we have to deal with. And then finally we've got 2/3 times 2/3 is 4/9. Okay, do you want to pause the video and have a go at simplifying these? Okay, for part A, raising to the power third is the same as cube rooting. We've got to cube root both of these. 27 cube rooted is 3. X cube rooted, that won't simplify nicely, so we'll leave it with the power notation. The next one, we need to raise the numerator and the denominator to this power. We'll start with the denominator, 100 to the power 3/2, or we can do 100 to the power 3 and then square root it, or we can do 100 square rooted and then raise it to the power 3. Probably easier to do this one, because 100 square rooted is 10, and 10 to the power 3 is 1000. And then on the top we're raising to the power 5 and then to the power 3/2. We multiply those together, that's n to the 15/2 all over 1000. And then the bottom one, we've got a 4th root, which is the same as raising to the power 1/4. This second term, we've got a negative power, which is the same as 1 over the positive power. Squaring and then raising to the power 1/4, where we can multiply those two together to simplify. 2 times 1/4 is 2/4, which is the same as 1/2. This bottom bit will simplify to 1/4u squared. And then when we multiply those two, I'll go back up here, multiply those two things together, we get u to the 1/2 over 4u squared. And this is like u to the 1/2 divided by u squared. And we subtract the index numbers when we're dividing. 1/2 take away 2 is -1.5, or -3/2. Okay, surds. This one at the bottom you should recognise is that. Okay, this is not a surd. These ones can't be simplified in the same way. If you were to type them into your calculator, you get a non-terminating decimal, which means that these are surds. Just like indices, there are certain rules that allow you to manipulate and to simplify surds, so that when you're calculating with them, you can transfer them into easier versions. This rule, for example, root 4 times root 10 is the same as root 40. So all that means, this rule, root 50 divided by root 10 is the same as root of 50 over 10, so that's the same as root 5. That's what those two rules mean. And we can use that fact to simplify. Have a look at these examples. Root 40 times by root 2 is the same as root 80. But there are lots of pairs of factors for 80. 40 and 2 are just one. Another pair of factors, another pair of numbers that multiply together to give 80 are 16 and 5. Why write that like that and then break it down into another set of factors? Well, because this is a square number. It's a square root of a square number. The square root of 16 is 4. So by using that rule to write it as a single surd and then breaking 80 into a different pair of factors, we can then simplify into this. Same thing in part B. 3 times 24 is 72, so that's the same as root 72. But then we can break down 72 into a different pair of factors where one of them is a square number. Root 36 is 6, so that's the same as 6 root 2. C, root 90 divided by 10 is the same as root 90 over 10, which is the same as root 9, which is 3. And then the bottom one, this is the same as, well, 27 divided by 64 won't simplify like this one would. But root 64 is a square number, so we can simplify that. Root 27 is not square, so that won't simplify into a whole number. But root 27 is the same as root 9 over 3, root 9 times root 3, where 9 is a square number. So that's the same as that. Okay, do you want to pause the video and have a go at these and see if you can simplify them? Root 12 is the same as root 4 times root 3. And root 27 is the same as root 9 times by root 3. That is 2. That is 3. So we've got 2 times 3 times root 3, which is 6 root 3. That simplifies to 8 root 3. Five root 7 won't simplify anymore. 7's a prime number. It's only got factors of 1 and 7, so we can't break that down anymore. 28 we can simplify. 28 is 7 times 4. Right, the 4 first and then the 7. This one doesn't change. Root 4 is 2, so this is 3 times 2 times root 7, which is 6 root 7, and that is the same as 11 root 7. Okay, quick recap of multiplying out brackets like this. Using the grid method, we've got x times x is x squared, minus 3 times x is minus 3x, 1 times x is x, and 1 times minus 3 is minus 3. And then these two x terms can be collected together to give you x squared minus 2x minus 3. Now, the reason we show you that is because you can do exactly the same method with expressions which look like this. 1 times 2 is 2. 1 times minus root 8 is minus root 8. Root 3 times 2 is 2 root 3. Root 3 times negative root 8 is negative root 24. So that's 2 minus root 8 plus 2 root 3 minus root 24. That bit can be simplified a bit further. Sometimes, like this one, you'll find that you might have the same surd, so you can collect two terms together. We'll see some of those later on. Okay, do you want to pause the video and try and do these ones for yourself? Right. 1 and root 2 in this bracket, 2 and negative root 2. 2 times 1 is 2, 2 times root 2 is 2 root 2. We've got 1 times negative root 2, and then we've got root 2 times by negative root 2. Root 2 times root 2 is root 4. Root 4 is 2, and a positive times a negative is a negative. So now we can collect together the whole numbers. 2 take away 2 is nothing. Then we've got 2 lots of root 2 add negative 1 lot of root 2 is 1 lot of root 2. So this simplifies to that. When you're revising these, what you can do, you've got a Casio calculator like this one. You can type in the expression, press equals, and check your answer. Now, obviously that won't explain to you what rules have been used and how to use them, but it will enable you to check your work and see if you've done it right. Part B, 1 and root 5, 7 and root 2. 7 root 5, root 2 times root 5 is root 10. 7 plus root 2 plus 7 root 5 plus root 10. None of these numbers have square number factors, so we can't simplify them. None of these surds are the same, so we can't collect anything together. That's as simple as we can write that one. Okay, one more thing. Rationalizing the denominator. To rationalize the denominator means to get rid of the surd on the bottom of the fraction. It's dead easy. The way we do it is we multiply the top and the bottom of the fraction by the same value, therefore keeping an equivalent fraction. But we do it in such a way that when we do the multiplication, things are going to simplify. So the top, nothing simplifies there, but on the bottom, 2 times root 15 times by root 15. Well, the root 15 times by the root 15 is 15. So we've got 2 times 15. We've got 30 on the bottom. The surd has disappeared, and then 5 and 30 both divide by 5. So we've got root 15 over 6. Again, one of these Casio calculators, type in exactly the expression that you're given, press equals. You can check whether or not you've got your answer right. And finally, do you want to pause the video and have a go at these? First one, multiply top and bottom by root 5. Root 5 over 5 times root 5 times root 5. Root 5 times root 5 is 5, so 5 times 5 is 25. That one can't be simplified anymore. For this one here, I haven't mentioned this type yet. What you have to do is you have to multiply by 2 minus root 2. The same term on the denominator, but with the opposite side. The top we just have 1 times by 2 minus root 2, which is that. The bottom we have this, which we looked at a couple of pages ago. So we can draw a grid. 2 times 2 is 4, 2 root 2, 2 times minus root 2 is minus 2 root 2, root 2 times negative root 2 is negative 2. And the reason why this has worked is because you see that this term and this term are the same, apart from one is positive and one is negative. Therefore, when we add them together, they'll cancel one another out. 4 take away 2 is 2. So this thing here is equal to 2. Exactly the same thing here. Multiply by 1 plus root 3. Draw out tables like this for the numerator and for the denominator, and what you end up with is 2 plus 3 root 3 plus 3 on the top. You end up with 1 minus 3 on the bottom, which simplifies to 5 plus 3 root 3 all over minus 2. If you want more practice, get yourself onto the Durham Learning Gateway. Look under GCSE past papers by topic, and there's one exam paper full of surds and indices questions.